factors of influence, like reliability. Therefore, reliability becomes a necessity that fixes up optimum warranty period to enhance the product demand. This course is intended to provide an overview on reliability engineering with prime focus on discussing various aspects of power system reliability. The patrons of the event are Professor Ajay and Director, Vishnu Institute of Technology, Andhra Pradesh. The coordinators for the same are Dr. Vivek Srivastav, Associate Professor, NIT Delhi, Dr. N. Padmavati, Professor and Head, ECE, Vishnu Institute of Technology, and Dr. Manoj Kumawat, Assistant Professor, NIT Delhi. It is a 2-week event with the first week program being online and the second one being offline. The timings of the same would be from 7 p.m. to 9:30 p.m. from Monday to Saturday. Today we have with us the guest speaker, Dr. Neeraj Kumar Goyal. Dr. Goyal has received his PhD from IIT Kharagpur in Reliability Engineering in the year 2006. He received the Bachelor of Engineering Honours degree in Electronics and Communication Engineering from MREC Jaipur, Rajasthan in 2000. He has served as an executive in Secure Meters Limited, Udaipur from July 2000 to July 2001. He is serving IIT Kharagpur as a faculty member since 2006 and currently serving as associate professor in Subir Chaudhary School of Quality and Reliability. He has guided approximately 40 MTech, 2 MS, and 8 PhD students. He has published 3 books and a lot many conference papers as well. He is actively engaged in providing research and consultancy services in the area of reliability and safety engineering to various organizations. We welcome you, sir.
Thank you, Manjot, and thank you, Dr. Vivek, for inviting me for this lecture. May I also have a brief overview that about the participants, that whether they are mostly from institutes or there are industrial participants also. So just an idea.
Most of the participants are from academia.
Okay.
They are professors, associate professors, research scholars as well, and couple of participants from the industry as well. We are having from one from the senior manager from the Vizag steel plant as well.
So thank you, Dr. Vivek, and thank you everyone for joining us and for this interaction today. I would preferably call it as a interaction in place of calling it as a lecture, right? So I would hope that you will raise your queries whenever you have. Since I will be on my screen, which is the presentation screen, I may not be able to see that if you raise your hand or if you raise any query through text. So therefore, I would like you to interrupt me and tell me that if you have a query, right? So maybe someone from organizer, maybe Manjot or someone else can just interrupt me that there is a query. I'll be happy to interact. And also, if you like in between, if you have any response queries, etc., you may write in your chat box, right? I'll come back to chat box and try to see it. So today I'll be briefly discussing about the reliability engineering. What is this about? Why we need it? And how exactly it's carried out. Anyone who has any prior experience with reliability, or if you have any brief idea or anything you want to know what is reliability engineering. So if anyone can tell what is reliability engineering, it will be great. It may not be entirely correct, like different persons may have a little different views about this vast area of research as well as the applications. If anyone has any idea, can you share? Anyone from the audience?
Sir, reliability can be considered as a field if we are having any machine and we have specified some time for its working, and if the machine works throughout the
Good
period
evening, sir.
as per manner, and
Yes, thank you. Thank you. Yes, yes. Yes, there was someone
Vivek, sir,
else.
good evening.
Yeah, good evening.
Good evening, good evening, ma'am. Good evening. Yes. Anyone else? So, as it is
Sir,
rightly
audio
told,
is not
not coming proper.
coming.
Good evening, sir. So this is Tushar.
Is my audio not proper? Anyone
Yes, sir.
else?
You are audible, sir. You are audible.
Okay.
Uh,
Otherwise, I'll
Basically,
use
sir,
headphones.
no, sir. You are audible quite clearly. And I just want to state that reliability engineering can be considered as the way of upgrading and improvisation in the engineering concepts, so that we can conclude all each and every mechanism in less time in efficient way, so that the time and cost which we are been spending on the vertical equipments can be reduced, and the machinery can be more reliable, considering that reducing the cost as a main point. Thank you, sir.
Thank you. Thank you. Very nice. So, as we have heard very nicely that reliability, we talk about failures as well as informed that importance of reliability, how reliability is helpful in meeting our requirements as well as bringing the cost down. Right? So thank you for informing. Anyone else? Fine. So I'll go ahead. First, I'll just briefly introduce myself as it has been already introduced. I think this will be repetition, so I'm skipping this part. Right? I've been working with various organizations. I have few book publications, 3 book publications with my PhD scholars. So around 47 journal papers, 13 conference papers. Okay. Books are in Springer and Ville. Then I have done around 19 consultancy projects with various organizations like DRDL, MPCIL, BARC, NPCL, MCE, ME. These are also defense organizations. Then Secure Meters is the one where I worked also, and later on I worked for as a consultant also for them. Then we have also worked for railways in terms of DLW, and we took one project later on here with DST. That was in collaboration with DST and Ministry of Railways. So effectively, we have worked many private industries also like John Deere, CESC. CESC is the electricity board kind for the Calcutta region. Then, so as we see that we have been working as a faculty here. I have worked with many companies which are not from one area, which are from various areas like railways there, atomic energy area is there, defense equipments are there, right? Then there are private, this tractor companies there, John Deere, right? And there is a also a company, Viset is actually was sponsored by the Vodafone. So Vodafone is also there. This is regulator, Atomic Energy Regulatory Board. Then ISRO is also there. We have worked with ISRO also. Then this is a research center for atomic research, which where we have worked. So if you see that reliability is applicable to almost everywhere, right? So I'm still using almost because I'm a probability person, so I cannot say everywhere because some place if you bring it out and say that it is not applicable, then it may be there. So here today we will be discussing about 4 major terms: reliability, availability, maintainability, and safety. If I say that you design a product, right? So whenever you have any product, even services, whatever product or services you are having, let us say you talk about any product. Let's say we talk about rail, right? So when we talk about railway is a product also, is a service also. So for railway, rail is a product, like engine is a product. The manufacturer also is producing locomotives, and your bogies, etc. as the product. But many times as a consumer, as a customer, many times we are using as a service. Like as a passenger, for me, railway is a service. I do not own anything. I just book a ticket. I use the services and I just forget about it. But the pupil who are running the railway, who is operating the railway, for them, railway is a product. They have to purchase engine, they have to maintain the engine, and they have to maintain the whole entire railway setup, like signaling, tracks, platforms, uh, monetary systems, and everywhere. So what happens that whenever we go and whenever we design, so if you are an electronic engineer, let us say, you may be designing certain PCB for certain purpose. Let's say you are designing an amplifier. So you are designing the system for amplifier, but for any system to work in the field, it also additionally have to meet these criteria which we are discussing here today. So these things, reliability, maintainability, availability, safety, these are to be applicable for almost all components and or systems or the services. So while you are doing the designing for the functions, for their purpose, you have to additionally look into the reliability, maintainability, availability, and safety. Do you agree with this? Anyone? If you do not design for reliability, what will happen? If you do not design for maintainability, what will happen? Let us see. Many times we design only for reliability. Maintainability may not be considered. Specifically, let's say if we talk about the products which are small, which are not very big, small assets, like let's say I'm using a mouse here, right? So for mouse, I may not be very peculiar about maintainability, availability, safety, etc. I may be more focused on reliability. So before going for this detailed one, let us first see what is meant by reliability. When we use reliability, when we use maintainability, when we use availability, when we use safety. So you have any product or you are taking any service as a customer. So railway is also a customer, railway is also service provider, right? So similarly, you may be using any other equipment. Let's say you are using car. So car is coming as a product to you, right? So car supplier is also a customer for some manufacturer. You have taken the car from the supplier. So for you, the car is coming from the supplier. So you are the customer to the supplier. Now the thing is that car is supposed to help you in traveling, give you a certain ambience, like it is supposed to give you an AC environment when you require, provide you sufficient cooling. It is also supposed to help you in navigation. It is also supposed to give you sitting comfort. It is also supposed to give you a very good feeling when you're sitting inside, and noise proof. It is should not be getting affected by the outside noise, or it should not create noise outside. Right? Same way, it should not pollute outside, or it should not get much affected by the uh, pollution outside. So many of such requirements are there. Using those requirements, you will be making a car, right? But will you be able to sell the car if it is not reliable, or maintainable, or available, or safe, right? What does it mean, right? You will not be, right? So to stay in the market, you cannot just make the car which is functional. You also have to make car for all these requirements. Any system you take, I have taken the example for car. You may take any example for any other product. So we have to understand what is meant by reliability. Why reliability concern comes into the picture? Because car, when I'm purchasing as a customer, it's fine. You are promising me very good feature, comfort, everything, right? But what happens whenever I'm using the car, it will fail. It will, whenever I'm using, it may have some failure, like AC got failed, AC doesn't work, or brake failed, brake did not work, or maneuvering when I'm doing, it is not doing properly. It is having some loop here and there, or my car is giving too much noise, or my car is consuming too much oil, right? What will happen? But at the time when I purchased the car, it wasn't fine. I knew that this car in good condition. So it was satisfying all the criterias. But as I started using the car may not be continue satisfying the criteria. Not only for car, any other system, if you consider, similar things will appear. So then comes the reliability criteria. So in reliability, the consumer would be telling an additional requirement, which is associated with all the products, that he wants that system to keep on functioning for certain period of the time without failure. Right? If it does not do it, then customer will not be satisfied. Customer will get, because if you purchase a car but next day it is broke down, what is the use of such car? Right? So that becomes a problem. So whenever we are purchasing the product, we also look into the reliability part. That means when I'm using over a period of the time, what is the chances that it will not fail? Or we say that we are concerned about the unreliability. That means what are the chances that it will fail? So we want that number of failures should be limited, should not be very, very high. So that's why we need. Why we need it? Because we want to tell this requirement along with our other requirement. What are other requirements? As we discussed, efficiency, comfort, look, right? And braking, etc., speed, horsepower, everything we have mentioned. But apart from that, we also need to tell that this car should not fail frequently, right? And how do we tell them? We use the reliability criteria for that. So that along with, as I'm telling that my car should be 1000 cc or 1200 cc. So I also have to say that my car should be reliable to this value, right? Because that is not generally covered in other design criteria. So designer, whenever he is making a design, he now also have to ensure that it does not fail, or the failure probability is below a required value, which is acceptable to the customer. We can never say that car will never fail, right? It can always fail with some probability, but we want that failure probability should be very low. That means it is almost nil chance that whenever we are using, but still it can fail. Sometimes we may still have a breakdown. 1 or 2 times in its whole life, if we have a breakdown, we can handle. But if it keeps on breaking down, it will have a lot of problem. So we need to specify reliability. Why? Because we are concerned with the failures. If the product fails, then we are facing problems. So we need to put a limit that how many times it can fail, or we need to put a limit that what are the chances of failures. Is it understood, everyone?
Yes, sir.
Anyone? Or you
Yes.
would like to add something, or
Yes,
you
sir.
would any other example if you would like
Yes,
to
sir.
say, right? So this is applicable.
Sir,
Yes, please.
I just wanted to say that it would be very kind if you can also include examples of software sometimes.
Software, right? Yeah, softwares are mostly similar way, like for hardware. Nowadays, no product is like software or hardware, or we say that electrical, mechanical. That's why nowadays, as at the institute level also, we have to change, bring change in the mentality, and we have to look into the combined system approach. That means that we are not thinking at the system as a pure hardware system or software system, because everything is interrelated. So like we discussed for hardware or the system point of view, we are mostly discussing from the system point of view, which includes software as well as the hardware. So software also have the same problem. Whenever you're purchasing a new software, initially you may find that this is working fine, but there are some cases where when you are trying to use, it may fail because there is certain bug. So whenever that bug get executed, it will result in a failure. So that kind of failure can be catastrophic or can be having certain kind of problems. So you want to ensure that the software which you're purchasing, that is going to work without any failure. That again, same thing, because software failure will also be same problem. Okay. Second question comes is, where is it applicable? So as I told, that reliability is applicable into most of the cases, right? Whenever you purchase a product, generally we have a associated time or we have a number of cycle, right? That means there is a certain time. Let's say I'm going to purchase a car. So as per the current, we earlier used to expect if I am going to purchase any car, bike, etc. We used to think that for 20 years I should be able to use it without much problem, right? With providing the required maintenance. But with current guidelines, government guidelines, we are having a 15 years period, right, for automobiles. So that means we are expecting that for 15 years, our car, bike, etc. should be working without much problem, without many failures, while we are also meeting other requirements. So this time, similarly, let's say if I'm taking a train, I'll be concerned that let's say I'm coming from Kharagpur to Delhi. So for me, reliability is that for my journey from Kharagpur to Delhi, that should be fault free. That means it should be within time. It should not be delayed, and it should not break down somewhere in between, right? So that will be my reliability concern. That means failure free, without failure, because if it is not able to meet its timing requirement, that is also failure. So that is, as it will maybe covered little later, that may be called punctuality failure. So that will be the punctuality problem, but that is again reliability because it is happening because of some problem either with the system or with the system management. So this time criteria can be different. Like here, time can be for car, it may be like 15 years. I want to use it without failure, or probability of failure should be very, very low. As I told that whenever we are saying without failure, the concept of reliability does not come into the picture because without failure will be not possible. We can say that the reliability has to be 0.999% or 999, that is 99.9% chances there that it will not fail. But we can never eliminate the probability that it will fail, right? So high reliability means can be some value, but less than 1 always. Similarly, we may be like for my Kharagpur to Calcutta, Kharagpur to Bombay, it may be around 1200 kilometers. So I want that. So I'll express my requirement in terms of kilometer, that for 1200 kilometers, there should not be any failure. Then it will be reliable for me, right? Same way, there can be sometimes cycles involvement. Many times we are using switches, we are using relays, etc. Where number of cycles is the important parameter, or wherever fatigue kind of operations are there. So there we looked at for a given number of cycles, it should not fail. Right? When do we use it? So we will use it generally. Let's say if you are the designer and if you are the user also, then what will happen? Whatever unreliability is there, you will be facing that. But generally what happens? One is the designer, one is the producer, or the same is the designer and producer, but customer is different, right? So customer would like that the reliability which is being there is promised, some level of reliability is promised. And if reliability requirements is not being met, then some sort of compensation is provided so that user do not face all the problems because of unreliability. So in a way, the reliability is promised by the supplier or by the manufacturer, and the customer finally. So supplier may be service provider also, right? It may be service, or it may be a product, or it may be simple software. Whatever is being provided, that has to be reliable. And if it is unreliable, then the penalty has to be paid by the manufacturer. Everything otherwise, if you do not have this, then what will happen? All the responsibility goes to the customer. So customer has to take all the trouble and pay for all the failures, which is not correct. So reliability in a sense will transfer the responsibility to the producer. And because he knows, once we know what is the requirement, how much reliability he has to meet, it also helps the producer because then he will be able to understand that his product not only has to perform, but it also has to perform with a certain reliability. So he has to build the product for reliability also. So during the design, manufacturing, and during the customer or operation period, maintenance period, they have to ensure that reliability do not goes down. But if they know the reliability requirement, then only they will be able to do it. If they do not know the reliability requirement, they will not be able to do this. They will say, okay, I will meet it. Whatever happens, I'll see, because it is not coming back to him. But when he has to pay later on, he has to be make sure that reliability is built into the product or the services. I hope this is clear. Anyone has any query, or if you have anything to add, please add. So reliability is mostly concerned with a certain mission time, mission kilometers, mission number of cycles, etc. Right? So we want that for a certain time period or certain kilometers or certain number of cycles, the product do not fail. Next term is maintainability. So while reliability is kind of universally applied for most of the product, maintainability is only applicable to the product which need to be maintained. Generally, what will happen? The systems which are little costly. Let's say for my household, if I'm going to purchase a bulb, right? I will not be looking for maintainability, right? Because bulb cost around 100 rupees. I'm not much about the maintainability. I will see the reliability part only. So for bulb, when I'm going to purchase, I'm given a, let us say, 1 year warranty, replacement warranty, right? So it's a 1 year guarantee. If bulb fails within 1 year, they will replace it. No other maintenance type, nothing. So that means it's a simple terms and condition that within 1 year, if failure happens, we will get a new bulb, right? So there is no maintainability requirement here.
No, sir,
Yes, please.
sorry to disturb you, but I don't think you are presenting the presentation, but we can only see your face. The slides are not.
Okay, okay, just 1 second. You are not able to see what I'm writing?
No, sir, we are just.
No, not at all.
Oh, I'm sorry. Okay, thank you for reminding. I'll do one thing. Oh, it was not shared?
No, sir,
Sorry.
you have not
Yes, sir.
presented.
It is visible now.
Okay, I'm sorry. Oh, I was discussing so many things. Sorry. Okay. Yeah, online have these kind of issues sometimes. Fine. So we discussed this part, reliability part. Right? Now we will discuss this maintainability part. Right? So maintainability will be applicable for the product which requires the maintenance. Right? But as I discussed that bulb, if I'm going to purchase a ball pen, right, etc. Earlier ball pen were also repairable or maintainable in a way because we were trying to bring down the cost. But so wherever refill was finished, we were going for purchasing a new refill and filling it up. Nowadays, as the life of the ball pens have increased, means whenever the ball pen itself will work for maybe for some time, quite little longer than it used to be. So because of that, what has happened by the time the refill finish, we are also feeling that the ball pen is no longer required. So we generally change the ball pen rather than the refill. Right? Why this is happening? Because the cost of refill may be almost same as the ball pen itself. Right? But if ball pen is costly, refill is very cheaper, we may be going for the maintainability. So maintainability requirement is generally coming with the complex systems. Wherever we have the mostly requirement is coming from the cost part. That means the system is costly. And by not replacing the entire system, by replacing a part of the system, or by repairing the part of the system, we are able to keep it functional for a longer period of the time. Is it fine, everyone?
Yes, sir. Yes, sir.
Right. So we need maintainability for those systems which are maintainable, which need to be maintained. And every system may not be maintainable. Every system may not require maintenance, right? So some are use and throw. So use and throw, we may not be going for this. We will be mostly looking into the reliability part of it. But whenever, let's say, even if we are going for mobile, right? So whenever we are purchasing mobile, whenever we are purchasing TV, whatever consumer goods we purchase. Similarly, this is also applicable for big things like there is a steel plant which need to be maintained. There is a nuclear power plant which need to be maintained. There is a complete, like if you purchase a car has to be maintained, right? So why maintenance is required? Because failure, whenever it happens at some little smaller level. That is the part level, or the we can say the component level. So if we are able to replace the part or the component, we are able to make that part or make the complete system functional again. So we are able to use the same system for a longer period of the time, right? By doing certain amount of maintenance. So maintainability is required. In a way, what is happening whenever we are doing maintenance, we are enhancing the life of the product, right? So reliability is related with life, that we have a certain life, and that is a probability that for a certain life it will be working without failure, right? But for maintainability, what happens? But whenever failure happens, then life is over, right? Failure means death. So after that, there is no return back. But this maintenance is providing us two kind of facilities, right? Either we, even if it is dead, we know that there is a certain fault. It's not complete system failure. So we know, like for human body, we may have some problem with the hand, some problem with some other organs. So what we will do, we'll try to repair, or we will try to make it better. So same way here for the system, we would like to remove those small things, because system is complex, because system has many items, system has many parts. So we are able to have it. So that's why we need it. But if system is very simple, one or two parts only, you may not be looking into the maintainability, because if one part fails, you have to throw it away. There is no reason to uh, repair one and then again do it, right? So it is needed because we want to understand how much time it takes to repair, right? Repair or maintain. Okay. So repair time is the concern here. How much time it takes to repair? Because what happens whenever you're doing the repair, you cannot use it. If let us say my car is requiring repair, whether car is requiring repair, generally we use two kind of things: preventive maintenance and corrective maintenance. Preventive or predictive maintenance and corrective maintenance, right? So, or we say predictive maintenance. This is the. So here in corrective maintenance, or preventive maintenance, in both cases, what will happen when you are doing maintenance, whether it is like for software also, what happens during software? Software is a maintainable system. Software is generally not a like one time only. Software has to be maintained. So like real-time software, they cannot be maintained when these are being operated. So like daily or weekly or monthly or yearly, they have to give you a downtime, and that downtime will be used for software repair, in which database will be corrected and other problems will be corrected, and it will be working again. So every software system which you're using, you will see generally, like for railway, we see that this is not working from somewhere around 11 o'clock to some morning. Similarly, banking systems, you will see that they, for certain hours, they are not available, right? Why? Because they are under repair. Software is requiring repair, and because of that, the system has to be put in the down state. So software repairs, hardware repair, whenever we are doing, so it is also applicable to all cases wherever repair is feasible and repair can extend the life. Right? Otherwise, what will happen? Because reliability cannot be made infinite based on the technology, based on the component. Let's say we are going to purchase any, let's say bike we purchase, right? For bike, the major problem is that some parts do fail quickly, right? Like filter. So because oil filter has to work continuously, so it can get choked. Now, if filter get choked, and because of that, what will happen? Your bike will also start creating problem and it may fail. So you know that filter is a very small problem and filter is not very costly also. So rather than considering it as a complete bike failure and replacing it, what you can do, you can timely maintain the filter. You can frequently change the filter, which is not so costly, and you can get the much higher life from the bike. If you haven't changed the filter frequently, your bike might have worked only for 1 year or 2 years, right? But by replacing the filter, you are able to get the life of the bike for almost 15 years, 20 years without any problem. So a system is consisting of various parts. All parts are not equally reliable, and system reliability will be governed by the least reliable component or least life component. The least life component, if you are able to repair or if you are able to do the preventive maintenance policy, what will happen if you repair them or if you replace them time to time? With that, you will be able to ensure that your system life is increased. System life is no longer limited by that component, because no two things have the same life. Every technology has a different life. So maintainability will help you to doing that. It will also help you that if some failure happens, you repair it and you will be able to get it in working condition again. So it is useful, especially in the cases where the systems are bigger in nature, systems are uh, costly, right? So that's where the maintainability will come into the picture. So maintainability deals with the repair time. We have to make sure that repair is completed within a certain period of time. So let's say when I purchase a bike, right? So if I'm having the two different suppliers, one supply, let's say I'm going for, let's say TVS, another I'm going for, let's say Honda, right? So they have their own service station. So when I'm going to their service station, I'm going to spend certain time. So if that service station is good, what will happen? My time for repair or time for maintenance will be less. If one service station is providing me that I pre-book my everything, my arrival there, departure there, and they are making sure that within 2 to 3 hours my all repair is done and it is given to me. It's scheduled like that. And another is not so well managed. And in that case, what will happen? I go there, I wait in queues. I will wait for the repair person will not find things. He need a repair. He need to replace certain part, and he will say that I don't have the part. I have to wait for one week or 2 weeks to purchase the part or get the part. Then only I will be able to replace. So which one is more maintainable? Which one is having high maintainability? Anyone? Anyone? Higher maintainability means what? Anyone?
So the one which can be available for use in the minimum time.
Minimum time, right? Thank you. So maintainability means it is able to repair within a given certain repair time, right? So the repair service which can be completed in lesser time, that is going to be more useful for you. That is going to reduce your downtime, and that is also going to reduce your problems. So whenever we are purchasing any equipment, we always see that, let us say I'm going to purchase any I know that one device, like I'm going to purchase AC, I have multiple options. I can purchase from, let's say, Philips, I can purchase from, let's say, this Voltas, etc. But I know that I have a service station which is near to me for the Voltas, but that same service station is not providing the services for Philips. For Philips, someone has to come from a distant, and it will take more time. So when I'm purchasing the AC, though Philips AC during the period of the use. And when I require the repair, if I have to spend too much time on getting it repaired, so much time will be lost, so much energy will be lost, and it will be hectic for me. So why should I go for that? So I also demand for high maintainability in this case. That means the repair time has to be less and it should be smooth. I should be able to finish this repair within a very small period of the time, so that my repair cost is small, repair time is less, as well as repair is effective. I hope this is clear. Anyone who would like to add to maintainability? Yeah. Then comes the concept of availability. So availability is again related with the system which are repairable or which are maintainable. So what happens whenever system is being
I think Professor Goel lost his connection.
Yes.
Yes. Yeah, please, we can wait.
Hi, good evening once again. Sorry, I think it was disconnected, right?
Yes,
When
yes.
I get disconnected, so that's where the problem is. So I'll keep this window up so that if there is any problem, you'll come to know. I think we discussed maintainability. Everyone understood that?
Yes, sir.
Right. Maintainability was clear. Anyone would like to add something to maintainability to what we discussed? So in reliability, we are looking into the life. That means it doesn't die or it doesn't fail. In maintainability, we are looking for repair time, right? That means minimizing the repair time, maximizing the life, right? And in availability, we are looking for some combination of the two, that out of whole life, how much it is in working state and how much it is in down state. So this is our down state and this is our up state. Okay. So here we want to know that what is the proportion by which it will be in up state and it will be not in down state. So that means it gives you the probability that the system is in working state and not in failed or repair state. Okay. So in a way, for repairable system, it is also telling us that how much we are able to use our system, right? So if I'm using anything, let's say if I'm using software system. So for software, let us say 2 hours is the downtime per day, right? I have to maintain it. Compulsory maintenance has to be provided for 2 hours per day. What happens? So I'm able to use it only for 22 hours. Right? So 22 divided by 24 will become my availability. Same way for anything. Let's say I'm using my bike. So for bike, in a year, I have to spend some time for repair or maintenance. Like I have to check many times for the air pressure. So air pressure time will be spent, which is non-functional time, which is the time I'm not using the bike for maintenance. Sometimes I'll be going for the um, uh, regular repair once in a year. So that will also be spent around 6 hours I'll be spending there, right? So like if I want to know how much is the availability, how much time I'm able to use it, right? That will come as the uptime divided by the total time. Anyone saying something?
No, sir.
If there is any query?
No, sir. No, sir.
Okay, same way like for mobile system, like say when I was discussing the mobile part also. So we are making a certain call, right? So can you tell where is that like whenever we are trying to make a call, we talk about availability, network availability. We never say network reliability, right? So why we say network availability? Because we are discussing whether network is available to work or not. So our work will happen or not. That will depend on whether signal is available or not. You don't say that signal is reliable or not. So network, whenever we are making a call, whether call is made or not, that is depending on the availability. So that will depend on various things like whether sufficient signal is available or not. This will also depend on whether the person whom we are trying to talk, whether that person is available or not, right? So it is availability that we are trying to make a performance. We are trying to use it, but the system is not functional. So that's where we are not able to use for the purpose, right? So that's why we need to use availability for these kind of cases where the system can be in two state, up and down. So we want to know what is the probability that system will be in working state or will be available to work. And second case that one system will be in down state. Same way for mobile network or mobile call. If we see, if let's say we are able to connect the call, that means then our availability criteria is completed. But during the call, it should not get disconnected. Then it becomes the reliability criteria, right? Because there is a mission that I want to make a 10 minutes call, 5 minutes call. So during the 5-minute call, it should not get disconnected. It should not be dropped. So if call drop happens, then that is the reliability problem. But call not connecting is the availability problem, right? Can you give some examples, anyone? So wherever we have the system, generally system will always be in two state, but after down state, if it can come back in up state again, either by repair or due to certain conditions, which when removed, it will be working again, right? In that case, only availability will be applicable. In reliability, we have only like this, up and down. After down, there is no up, right? But when there is a up down state, both possibilities are there. Then comes the availability concept. We have to look into the probability that it will be in up state, not in down state. Okay. Is it okay? So this will give you an idea, like for a railway system or anything which you're purchasing, you know that how long you are actually using it out of the total time and how long you have to spend in waiting or in repair and how long you are able to use it for the purpose. So in a way, it is telling you that how much use you can make out of a product or the services. It's applicable to all these such cases wherever two states are possible and they are in anytime you may find the system in any stage. Right? And that's where you can use it for the purpose that like let us say try, we consider try, like try has to use they cannot use the reliability criteria also they use, but they also have to use the availability criteria, right? So they will use availability criteria. Let's say they say 98%, right? 98% availability per day. That means for 98% of the time, the system should be available. The signal should be available. 2% means out of 24 hours, if we look, 2% will be if we say 25 into 2, that will be around 0.5. So approximately half an hour downtime will be allowed. If there is a more than half an hour downtime in a day, then they may be penalized. So these kind of policies can be built up, and these kind of policies will help you. So the user will also like that my system availability should be high. It should not happen that most of the time I'm not able to use the system because it is not available. It is either under repair or some condition is there. It is waiting for that, and that condition is not there, so I'm not able to use it. Yeah. Any query about it, or is it understood availability?
Yes, sir.
Sir, one
Anybody
query,
would
sir.
like to? Yes, please.
Sir, let's say there is a system which is available for 8 hours in a duration of 10 hours. So I
Yes.
can say the availability is 80%.
Yes.
But in this case, let there be a case when the system is down for only one time, when it is not available for 2 hours. And there is another case, the system is again not available for 2 hours, but it is like 1 hour it is working, 15 minutes it is not working, then again 2 hour working, then 15 minutes not working, that way. So availability will remain same in both the cases. But how can I define the reliability in both of these cases?
That's why. So that's why we need to define both the things separately. We cannot define like just availability and we expect that reliability criteria will be met. So that's why whenever we are defining, we have to define reliability separately and availability separately, because there is a possibility that for the same availability, like in this case, if you see you want to use the system for, let us say, 7 hours, you want to continuously operate for 7 hours. So this is going to give you high reliability here. But in this kind of case where there are frequent interruptions are happening, frequent interruptions are not necessarily against availability, but they are against reliability. So number of interruptions is against reliability, but how long this interruption happen, that is against availability. So that's why whenever we are specifying, we have to specify both. We cannot specify one and expect that our all concerns are addressed here. Is it okay?
Yes, sir. Thank you, sir.
You can add, you can cross question if you have anything. Yes, someone was telling something.
And sir, if I need to link maintainability to the same case, then I can say that like the system on the lower side, which is having a 1 hour downtime 2 times, it is having higher maintainability than the above one, right? No, sir?
True. True. This is less reliable, but more maintainable. That's why you are getting the higher, similar availability than this case. This case, and this case, if we compare, this case reliability is high, this case maintainability high. So, but availability is similar in both cases.
Thank you, sir. Clear, sir.
But what happens? Reliability is related with the risk, as we are coming to next. Because failure, whenever it happens, it is not only time of downtime which is important. Every failure may also lead to certain other kind of problems. Let's say breakdown happens. So whenever breakdown happens, not only duration of breakdown is important, but whenever breakdown happens, it leads to many other problems. So and especially if the concerns are related with safety, concerns are related with some operational, and it can influence other dependent, because in this world nothing is like independent. So if you let's say breakdown happens in one system, it may affect the performance of other systems also. If that kind of scenario is more there, then you will be concerned about each breakdown. So whenever frequent interruption is happening, that is that is worse because reliability is poor. So we have to look into that. What is our system requirement? Again, as we will see, that this depends on what kind of consequences are there. So we have to look everything in terms of consequences. Next term which we are coming is the safety, right? So there are many times confusion, safety, security, right? Generally, safety is the term which is used whenever we are indicating the human impact. So whenever we do something or something fails, so whenever failure happens, there may be many kind of consequences. Sometimes it is just an inconvenience, right? Even though it fails, but it doesn't create any much effect on us. We are just irritated and we are just seeing that why it is not happening. why it is taking more time, etc. Right? So if train gets delayed, it may not be a safety problem. It may be just an inconvenience or the loss of some work, money, etc. But if train meets an accident, or if you say fire is there in your car, or if you say fire is there in your operational environment, or if you say in your office, right? What will happen whenever things goes wrong in the direction which can affect the persons which are using it or which are in vicinity, or it can damage the environment, right? Or it can have the losses which can have the devastating effect on the pupil health, as well as the sometimes financial is also considered, but financial should not be considered as the main criterion. Safety is mostly coming into the picture when there is a possibility of harm coming to the human being. So this can be injury, this can be some sort of health impact, there can be some sort of life threat to the life. So then comes the safety consequences. So every failure, as we discussed, things can fail, but things can fail in millions of the ways, thousands of the ways. So every failure, whenever it is happening, let us say we are using a car, one failure is that AC is not giving sufficient cooling, right? So that's affecting only our comfort level and may not be creating very severe health impact. But if AC is not at all working in the very high temperature requirement, that means we are traveling in certain places where temperature is very, very high. That can make you sick. Or let's say if we say the AC is not working when you are using certain thing, let's say you're transferring someone's organ, right, in the AC box. So if that AC fails, what will happen? That organ is lost, which is a very big failure because the person, the patient which is waiting for the organ may die. So it's a safety kind of consequence. So every failure cannot be treated as same. Yes. Yes, please. Okay. So every failure cannot be treated as same. Different failures have different impact. So the failures which lead to the safety consequences, that is, which can cause the harm or the threat to the life of the pupil, those kind of failures should be separately analyzed.
हाँ भाई तुम्हारा बहुत दिन है अबे 2-2.5 साल दीजिए
Yes, sir. Please continue.
ठीक है
Sir, are you muted?
I think I was muted. Okay.
Yes, sir.
Am I audible now?
Yes, sir. Yes.
Okay. So in safety, what we do, we are concerned about the consequences of failures, which will lead to the harm to the pupil. So the systems where, like when I'm using a car, there's a possibility that if car malfunction, then I may be having the injury. I may have injury like my hand. I lose my hand. I lose my legs, or I lose my life. Same way, if I'm using motorcycle, same things can happen, right? So whenever failure due to some reason, maybe due to accident or maybe due to the system failures, if that happens and that is going to lead to the threat to my life, then it is a safety concern. And whenever there is a safety concern, we have to make sure that concern is addressed and that possibility of having such uh, case is minimized. So that means the reliability of the function which is leading to safety consequences of failure, that has to be made more reliable, right? So wherever the product which has some way of which has the possibility of harming you, that means wherever hazard is possible, then you have to also make it sure that it is safe also. So safety is related to generally wherever energy is there, there will be some safety concern. And if I'm using any product, some sort of energy will be involved. Otherwise, there will be no use. So most of the product, whatever we use, there will be some sort of safety concern. So wherever safety concern is there, you have to do the safety assessment and analysis. So safety, how do we measure? Safety is a freedom from unacceptable risk, right? That means what is the probability? In a way, we can say we have a certain risk criteria. Let's say we cannot completely eliminate, like let's say, uh, can
Can
we
you
completely?
elaborate hazard?
Yeah, hazard. I'll come little later. Hazard. I'm going to discuss these terms in little bit more detail also little later. Hazard is the potentials. Like let's say if you're using petrol, then fire hazard is always there. But fire doesn't happen always, right? Hazard means there is a possibility which can always happen. And this possibility is not a good possibility. This possibility is a bad possibility, which is a possibility of harming you. So whatever can go wrong can be called as a hazard. Okay, but hazard doesn't happen always. Hazard only happens when there is a certain failure, certain accident, whenever they happen. So there is a probability associated with each hazard. So we know, and that probability along with the consequences, we call it as a risk. So I'll discuss this a little later. But hazard, whenever it is there, the possibility of harming a person is there, safety hazard is there. That means in that case, we have to make sure that the possibility or probability of such hazard is minimized. And whenever that hazard happens, we are able to make sure that we are able to come out of it without much damage. Is it okay?
Yes, sir.
Right. So in safety, what we say safety is the that risk is less. That means we are having certain risk criteria. That means there is certain specified level of risk which we can tolerate. Like I was discussing that if I say that I will not accept, there should not be more than one accident per year for bike being used on the road, right? If I set such a criteria, and if I say that if the risk is higher than that, I'll stop all the bikes. So that in that case, what will happen? We have to stop traffic at all. We have to say that bike cannot be used, right? Because there's certain amount of risk which is already there. The bike, if we are going to use, there'll be certain amount of risk associated with that. So what is the risk which is acceptable? Like how much bike accidents we can tolerate per year? So the society can decide, and based on that only the system will be made and operational. If you want to reduce the bike operation, what you have to do, you have to have a very high technology in the bike. You have to wear so many things. You have to make sure that the control systems which are used for traffic are very strict. The rules and regulation implementation is very strict. But whenever you do that, what will happen? Your freedom, your ability to work, and your mental pressure will also increase, and everything will get affected. So in a way, you are losing something whenever you want to go for very high safety or very low risk, you may be losing. So how much is the acceptable value? You will decide. And if your risk is below that acceptable value, the system will be considered as the safe system, safe to use. If the system is not safe to use, you have to stop that system from the operation, because safety is paramount. There is nothing above safety. Okay. Is it understood, everyone? Everyone, could you get it?
Yes, sir. Yes, sir. Yes.
Right. So it is applicable for those cases, and it is useful in deciding these policies, and safety policies then govern all such facilities, and regulatory bodies are monitoring the risk, and they make sure that system remains in safe state, right? So whether it is traffic police, whether it is AERB, whether it is different other organizations, they will make sure that system remains in safe state. That means the risk from the system is below acceptable level, right? So let's say like general definitions for these. So what is RAM's definition? So what is reliability? Reliability is defined as the probability that the product or system will perform the required function right? For a given period of the time, right? So that means for this period of the time, which is my mission time, we can say the system should continue performing this function. But as we know that performance of the system is not only defined by the system, but it also depends on how do we use it or where do we use it, in what conditions do we use it. So operating conditions is also another criteria. Different operating conditions may exhibit different reliability from the system. So whenever someone is promising you reliability, he will also define the boundaries that within these boundaries only the system has to be used. Then only we can assure reliability. If the boundaries are violated, then reliability conditions will not be met. So same warranty, etc., you will not be able to get. Okay. Availability is defined that probably that a product is in state to perform the required function under given condition at a given instant of time. That means at a point of time of our concern, we want to know whether the system is in working condition or system is in not working condition, okay, or is in down state. We can also get it over an interval, right? And considering that external resources are provided. That means within an interval, what is the probability that it will be in up state and not in down state? Again, maintainability, same way we define to that. What is the function for maintainability? Function is that to be retained or restored to in a state in which it can perform the required function. So that means here in maintainability, we are making sure or we are asking that the system should be in functional state, maintained in a functional state, right? And but what are the things which can affect maintainability? That how do we do the maintenance? So maintainability cannot be defined unless you provide the maintenance procedures, right? So maintenance procedures conditions has to be defined. Then only and number of maintenance persons, tools, availability of manpower, tools, as well as the spare parts. Everything has to be put up. Then only we can define or calculate the maintainability. If they are violated, procedures are changed, resources are changed, or the tools, parts are changed, what will happen? Maintainability will also get affected. So maintainability, whenever we are defining, we have to provide an idea about these also, that under what conditions we are talking about. Similarly, safety is the freedom from unacceptable risk to human health or to the environment. So that means there is certain level of risk which we consider as acceptable, because we can never eliminate risk to zero. We want to eliminate risk to zero, but that is only possible when we do not do that task, right? So from any source, if we want to make risk equal to zero, then we have to stop doing that. There's no other way, right? So but if we don't want to do that, we want to keep using our resources. That's how we have progressed. So we are ready to take certain amount of risk whenever we are doing certain activity. And that is our acceptable risk. What is risk? Risk is a combination of two things. One is the frequency of loss, and another is the how much is the loss. So amount of loss multiplied with probability of loss for all possible losses cases. So for all possible conditions where you may exhibit a loss, you take the amount of loss and take the probability that that kind of condition will arise. You multiply the two and you take the summation of it. So in a way, it will be like summation of PI and CI, right? Where PI is the probability, CI is the consequence. So PI is in a way is a probability of consequence I, right? If you sum the consequences with their probability multiplication, in a way you will get the amount which is the expected value of consequence or expected value of loss. So in a way it is telling you on an average how much loss you will be having. Or what is the expected loss? Is it okay, everyone?
Yes.
Yes.
I have a question. I have a question. In real-time system, we require more reliability. For example, in aeroplanes,
Yes.
etc. These are comes in the category of real-time system in which there is a chance of life or risk. So how or what parameters or what we do for increasing the reliability in that cases, is there any something much more we can do for the reliability for such type of systems?
Yes. So what happens that first thing is knowing that how much reliability is required. The major problem we are facing is to know that how much reliability is required. So for doing that, we have to look at the risk part. So risk is telling that how much is the unacceptable risk. So that means consequence is known to us. So if I'm having high consequence, like say there is a safety consequence. So airplane, what happens whenever it fails, it will lead to multiple life loss, which is a very severe condition. So how do we make sure that risk is low? By reducing the probability of failure. So this probability of failure will be brought down when there is a high consequences where loss is high. So whenever loss is high, we demand a high reliability. Like for aeroplane system and other systems, the reliability demanded will be high. Once the reliability demanded is high, then the designer who is making the system, he has to use the design ways in which he has to ensure that the reliability of the system is high. So he will design, he will simulate, he will also test it more. He will also make sure that such failures are avoided. So analysis, testing, and design efforts are much higher whenever we want to achieve a certain reliability. So there are various possible ways of improving reliability. I'm not considering that here. Maybe in some other lecture someone will cover. But you have to focus on material selection, you have to focus on part selection, you have to make sure that stress and strength is balanced. You have to make sure that if there is no other way of improving reliability, then you have to provide duplicacy in the or redundancy in your system so that if one fails, then another will take care. If nothing can be done, then you have to provide some sort of safety procedures, which will make sure that even if failure happens, then the consequences are not too high. They are somewhere taken care. Right? Is it okay?
Yes, sir.
So this is the definition part. Now, if we see that reliability techniques, whenever we are discussing, so what happens like whenever a system is failed, any failure will be called as a reliability failure, right? But safety will only increase by controlling the failures which lead to the safety consequences, right? Let's say for my car, let's say if I'm able to deal with the failure related with the AC not being efficient enough, right? So AC efficiency is low or fuel efficiency is low. So that is a reliability failure because that is my performance parameter. But that is not safety consequence. Since it is not safety parameter, it will not improve the safety. If I improve efficiency of my car, it may not improve the safety. It may improve the reliability because my car has a certain efficiency requirement, right? Or certain cooling requirement. So safety will only improve if I'm working on reducing the failure probability or consequence of those failures which are safety related. Is it okay? So like accident can occur without component failure. So I don't have any control over that. So bikes on the road, if they are meeting an accident, then what bike manufacturer can do, right? He cannot improve much there. So even if he makes bike reliable, the safety may not improve, right? While components can fail without causing an accident, right? So though failure is there, but it may not be leading to the accident. So those failures will be reliability failure, but will not be the safety failures. Similarly, if we compare reliability and availability, then as we discussed earlier, as we already discussed with a good example that why high availability is not high reliability. And so there may be more interruption, but you may achieve high reliability at the and many times what happens that to achieve high reliability, like what happens, we want to travel in train from one end to another end, right? So we want to achieve high reliability, it should not break down. To reduce the chances of breakdown, what we are doing, we are decreasing the availability. How? Because we are doing too much preventive maintenance, or not too much, we are doing the preventive maintenance on this. So the every time one trip is completed, the equipment will go for repair, some sort of repair, right? Every time of the certain frequency. So it has to spend some time in repair. so that during the trip it does not fail. So in a way, what is happening to improve reliability, we are decreasing the availability because it is spending more time under repair. Is it understood, everyone?
Yes, sir.
Okay. Now, how much time we have spent? Can we take a break?
Yes, we can take it. Take the break.
Let us take a break, maybe 10
Yeah.
minutes.
So it's around 8:25.
Okay, so let's meet 8:35 or 8:40 around, right?
So
Anyone
15
has,
minutes.
because we are discussing in between, so it's, I think that should be okay. So let's make a 10 minutes or 15 minutes break. We can have 8:35. Let's say 8:35 we will meet again, right?
Sure, sure. Thank you. So we are here only. So just we will keep muted or the mic and camera, and we will be resume after 15 minutes.
Okay, sir.